Alright, today we're going to be talking about solving systems by graphing. Our objective is that we will be able to solve a system of equations graphically. When graphing, the solution to a system is the point where the lines intersect. So, in our examples, find the solution to the system of equations by graphing. So I'm going to do this in different colors just to make it easier to see. I'm going to do that one in pink, and this one in blue. So I'm going to start at our y-intercept of -1, and then our slope is +1/1. And then I'm going to use a ruler to connect my dots because I want a perfect line since I'm looking for the intersection point. Draw arrows on the end. And now I'm ready to draw my pink line. So I'm going to start at the y-intercept of +2. I'm going to go up 2/1, and to help me make a few more dots, I'm going to go down and left. I'm going to use my ruler to connect the dots. Draw arrows on the end. And then I'm going to look for where they intersected, which is right here. So they intersected at -3, -4, so my solution is -3, -4. The way I could check is by plugging in. If I plug in -3 for the x, y equals -3 minus 3, does that equal -4? It does, just like our thing said. And y equals 2 times -3 plus 2. 2 times -3 is -6 plus 2 gives us -4, just like it should. So y equals 3. We remember our little hint, hoi vux, means we're going to have a horizontal line since it's y equals just a number. So I'm going to go to where y equals 3, and then I'm going to use my ruler to make a horizontal line. For my second one, x equals -2. Since it's just x equals a number, we know it's a vertical line, so I'm going to go where x equals -2 and draw a vertical line. And they intersect at the point -2, 3. Which makes sense because they told us that x is -2 and y is 3. For our first line here, we need to recall how to find the x and y intercepts when it's in standard form. Remember, we're going to ignore the y to find the x, so -2x equals 12. Divide by -2. We get that the x-intercept is -6. And if we ignore the x, we have 6y equals 12. Divide by 6. We get y equals 2. So I'm going to go to x -6 and y 2 and use my ruler to connect the dots. And now I can graph my second line. I'm going to start at my y-intercept of -1. And my slope is -2/3, so I'm going to go down 2 and right 3. Down 2, right 3. And then I can use my ruler to connect the dots. And we see that they intersect right here at -3, 1. So let's check it. -2 times -3 plus 6 times 1. -2 times -3 is 6. 6 times 1 is 6, which equals 12, which is what our equation said it should equal. And if I do -2/3 times -3 minus 1, -2/3 times -3 should be +2, minus 1 is 1, which we had for our y value. So they both work. What's it going to look like when we have no solution and infinitely many solutions? So number 4, I'm going to start at my y-intercept, then go up 2 over 1. Use my ruler to connect my dots. For my second equation, 2x equals -4, so x equals -2, and -y equals -4, so positive y equals +4. So I'm going to go to x equals -2 and y equals 4. If I use my ruler to connect the dots, if you notice, these lines are parallel. They're never going to intersect. So therefore, there is no solution. Anytime we have parallel lines, they have the same slope, so they never intersect, and we're going to have no solution. In number 5, for our first equation, I'm going to start at -4, then use my slope of 1, so up 1 over 1. Connect the dots. For my second one, 4x equals 16, so x equals 4. -4y equals 16. And when I divide, I get -4. So I got that x is 4 and y is -4. And we turns out that we have the same line. Whenever we have the same line, the same everything, they're all lined up perfectly, we have infinitely many solutions. So that's our answer here. Infinitely many solutions. That's all for today. Fill in your summary